We're on a new episode of Aftermath here. For my algebra students, we are in lesson 38, and lesson 38 is on ratios. Now, ratios are actually a very simple concept. I've written a few on the board right here. These are all actually equal ratios. Now, if you're looking at it, you're probably thinking, those aren't ratios, they're fractions. Mr. Howell doesn't know what he's talking about. But fractions and ratios are actually pretty much the same thing, just two different ways of looking at the same thing. We often write ratios as fractions, and that's exactly what I've done here. The only thing that's really different is how we define it. A ratio is actually a comparison of two numbers, and usually we don't think of a fraction as being that. But really, they function exactly the same way, they work exactly the same way. So, if we were thinking of these as fractions, we would say it's 3/4, 6/8, 15/20, and 148. What a fun fraction that is. Unless you're a hobbit, you could call it 11d1, I guess. But either way, that's a big fraction. But like I said before, these are all actually equivalent fractions. 3/4 we can double and get 6/8. 3/4 we could have also multiplied by 5 and got 15/20. And we could have even multiplied it and got this last one. So they're all actually equal. And remember, we said ratios work the exact same way as fractions. The only difference is we're saying that a ratio is basically comparing two things. So instead of saying 3/4, I would say 3 to 4. I would say 6 to 8, or 15 to 20, or 111 to 148. Now, what we're going to do is we're going to learn to work with some ratios. And I'm going to take two of these. We already said that they're equal ratios, so I can say that they're equal. I could say 3 to 4 does equal 15 to 20. So the really interesting thing about ratios and what's going to make it easy for us to work with them is that whenever we have two ratios being equal here, their cross products also end up being equal. So if you look at this one, 3 times 20 is 60. Also, 4 times 15 is 60. So since their cross products are equal, that means anytime we have an unknown in here, like if one of these numbers was missing, we could figure it out based on that knowledge. Now, when we say two ratios are equal, there's a special name for that. That's called a proportion. And you can do lots of different things with proportions. For right now, we're going to stick with really basic ones like this, but we're going to look at a couple examples and see how to solve them. So let's look at that. We have two ratios that we're saying are equal. We call that a proportion. This one is 4 to m equals 21 to 5. And what we just said is that when we have a proportion, when we have equal ratios, their cross products are equal. So I'm going to write that as an equation. I'm going to say that 4 times 5, which is 20, equals m times 21, or 21 times m, which we would write as 21m. 21m means 21 times m. So 21m equals 4 times 5, 20. And then, like we would do with any other algebraic equation, if I want to know what m is, to get rid of that times 21, I just divide both sides by 21, and all of a sudden I have m equals something. Now, if I did that division problem, I wouldn't get a whole number. I would get a decimal or a fraction, which this is already a fraction, and that's a fine answer to have. You won't always get a whole number. It's okay to use the fraction 20 over 21. So that's what m equals. All right, let's go ahead and look at another example. And what we'll start to do is we'll take a word problem, get the information from that, and we'll write a proportion out and solve it. Our next one is a word problem. And that problem tells us that in the barnyard, the ratio of pigs to goats was 7 to 5. So I went ahead and wrote that information down. We have a ratio. We're comparing the number of pigs to the number of goats. That ratio was 7 to 5. Now we need to remember, when we set up a proportion, both ratios should be the same thing. They should both have pigs to goats. We shouldn't have one be pigs to goats and one be goats to pigs. They have to both be pigs to goats, all right? So that's what we need to make sure we do. Okay, the problem also tells us that we have a total of 91 pigs, and it asks us how many goats are there. So the ratio is just a boiled down number of a comparison. For every 7 pigs, there are 5 goats. Now, there's actually more than that, but that's just a comparison of the group as a whole. In the group as a whole, there's actually 91 pigs, and so we want to know how many goats. And so we're going to set up a proportion. We already know what our ratios are going to be. They're both going to be pigs to goats. And we already know what our boiled down number is, the actual ratio, pigs to goats is 7 to 5. So I'll write that as the first part of my proportion. And I'll say that it's equal to another ratio. Now the other ratio will also be pigs to goats, only now we're dealing with the total numbers, how many there actually are. We said that there are 91 pigs. That still goes on the top. We're wanting to know how many goats, and since I don't know how many there are, I'm going to use a variable in place of it. I'm going to call it G for goats. We're going to solve it the exact same way. We're going to say the cross products are equal. So I'm going to say 7 times G, 7G equals 91 times 5. And 91 times 5 is going to be 455. And so if I want to know how many goats there are, I've got 7 times the number of goats equals 455. To find just how many goats, I need to actually divide both sides of my equation by 7. That will leave me with just G on the left, and then once I do 455 divided by 7, I find out how many goats there are. Once you do that division problem, 455 divided by 7 will give us 65. And for some reason, I wrote that like a G. There we go, 65. So that tells us the number of goats is 65. And you can always kind of check and make sure it makes sense. Remember, every 7 pigs, we have 5 goats. So if we have 91 pigs, we should have a few less goats, and around 65 sounds good. So this was ratios, proportions. They're pretty simple. Later on, we'll get to more advanced ratio problems. We might even do a special video on them sometime as well. I hope you learned something today. If you have any questions or comments, go ahead and put one below. Go ahead and subscribe, and you can see new videos as they come out. See you later.